the properties of the wave. So first thing, how we can study the properties of the wave. So we can use a ripple tank for this. So what is a ripple tank? A simple tank which is, or a container which is filled with water. This is a real picture of the ripple tank. So what it consists of, a tray is there. This tray consists or filled with water. And we can produce wave here. How we can produce a wave? So if we want to produce a wave in a ripple tank, so this is a tray of the ripple tank and it is filled with water. And here we place an object. It can be rectangular object or it can be spherical object. If I move this object up and down, so what will happen? This will produce the disturbance in the water or it will produce water waves. What kind of waves are these? Transverse or longitudinal? What kind of wave water wave is? Longitudinal or transverse? So this is a transverse wave because the movement of the particle or vibration of the particle is perpendicular to the direction of the wave. So this is the direction of the wave and this is the direction of the particles. So particles are moving up and down and the wave is moving towards right. So why we use a ripple tank? What is the reason to study the properties of the wave? We use a ripple tank because number one, it is easy to produce the wave. And you can observe the waves easily. That's why we use a ripple tank to study the properties of the wave. You don't have to learn in detail about the ripple tank, just introductory topic that a ripple tank can be used to demonstrate the properties of the wave such as reflection, refraction or diffraction. So what is a ripple tank? A container which is filled with water and you can produce the wave in the container. You call that as ripple tank. Another picture of the ripple tank. So here we have a wooden support or elastic band. What will happen? Here is an object. So this object will move up and down. So as this object will move up and down, what it will produce? It will produce water waves. And we place a source of a light or a lamp at the top. So when we place the source of the light or lamp at the top, we can also observe the shadow at the bottom or on the screen. So today's topic, the main topic is about, these are some patterns which we observe on in a ripple tank. This is the main topic, which is about the properties of the wave. First one is a reflection. How we define a reflection? Property of a wave to change direction after striking a surface So when the wave strike the surface and it change direction, this property is refers to reflection. So how we can observe this reflection or reflection of the wave? So what we can do in the same ripple tank, because why we are using a ripple tank, it's easy to produce the water waves and easy to observe the water waves. If this is a ripple tank, and you fill this ripple tank with water, and you place an object in front of this. Inside the water, you place an object. At one end, you are producing the wave. This is a vibratory object. Using this object, like moving this object up and down. So as you move this object up and down, what it will create? It will create water waves or the disturbance in the water. So the water waves will travel from left to right. These water waves will strike the surface, it will hit the surface, and then it will bounce back. So when the waves strike the surface and return or bounce back, we call that as reflection of the wave. This is when you're looking from the sideways, but if the same way, if I look from the top, if you are observing from the top, like if you are observing from this point, so if you are observing from the top, and here is the object, this is the object, you're looking from the top, and the waves are moving or traveling. So as the waves strike the surface, as these waves strike the surface, they bounce back, and what we call that as reflection of the wave. So property of the wave to change direction after striking a surface is refers to reflection. The wave which strike the surface, that wave is called incident, and the wave which bounce back, that is called reflected. So animated reflection, like what happened if there's a wave, you can see here the waves are coming, they strike the surface. When the waves strike the surface, after striking a surface, it changes the direction. As the wave changes the direction after striking a surface, we call that as reflection of the wave. And if we measure the angle between the incident, the wave which strike the surface, that's called incident, and the wave which bounce back, that is called reflected. So this one is the incident, and the one which is changing the direction is known as reflected. The imaginary line which is perpendicular to the surface, this is in reality, it's not there, this is just an imaginary line which is perpendicular or 90-degree to the surface, that is called normal. And if we measure the angle between the incident and the normal, if we measure this angle, we call angle of incidence. And if we measure angle between normal and the reflected, that is called angle of reflection. So according to law of reflection, angle of incidence is equal to angle of reflection. The angle at which waves strike the surface is always same as angle at which the wave bounce back or bounce off. Is it clear? The wave is moving towards the surface or a barrier, it hits the barrier and it changes the direction. This property of the wave is called reflection. The
So
wave
can you
which,
explain one more time?
the wave which strike the surface is called the incident wave. Reflection means, like example, what is the simple meaning of a reflection? First thing, if I say a simple meaning of a reflection, if you have, say, a ball and you throw this ball towards the wall. So as the ball moves towards the ball will hit the wall and it will bounce back. What you call this? You simply call this as reflection. So what happened in reflection? The direction of the motion or direction is changed. So same thing happened for wave also. When the wave strike the surface or wave strike the barrier, it changes the direction, and as the wave is, example, moving towards the barrier, so it hits the barrier. As it hits the barrier, it bounces back. So as it bounces back, it changes direction, and we call this as reflection of the wave. The wave which is moving towards the barrier is called incident, and the wave which bounces back is called reflected. Is it clear? Is it clear? The concept of a reflection, a property of a wave to hit the surface and bounce back, we simply call that as reflection. And how we study this reflection? We use a ripple tank to study this reflection. So we can put a barrier in front of the wave. So example, here we put a barrier in front of the wave. The wave which is moving towards the barrier, that's called incident. The waves which are going out or after striking a surface changes the direction, we call them as reflected wave. So you can see the waves which are striking a surface here. So the wave which strike the surface, that's called incident. And after striking a surface, the wave bounce back. What we call that as reflected. Is it clear, the concept of reflection? And if you measure the angle between the incident, the wave which strike the surface, that wave is called incident wave. So the wave which is striking a surface, we call that as incident. If I draw imaginary line which is perpendicular to the surface, so imaginary line which is 90° or perpendicular to the surface, that line is called normal. And if we measure the angle between the incident and the normal, that is known as angle of incidence. The wave which strike the surface and bounce off, that is called reflected. An imaginary line which is perpendicular to the surface called normal. Angle between the normal and the reflected one is known as angle of reflection. And the angle between incident is always equal to the angle of incidence. Angle between the incident and the normal is always equal to angle between normal and the reflected. So if angle of incidence is equal to 30, angle of reflection should also be 30. If angle of incidence is 45, what will be the angle of reflection? If angle of incidence is 45, what will be the angle of reflection? that should also be 45. So according to law of reflection, whenever there's a reflection of a wave, angle of incident always equals to angle of reflection. Is it clear? So the one strike the surface is incident, one bounce back is known as reflected. So if the question is identify the incident here, so the one which is moving towards the surface is incident, and the one which bounce back is simply known as reflected. This is another. Salman, this is about the reflection of the water waves. Reflection can happen with us depending on the texture of a surface, but this is about the water waves. So water waves, even a surface is a rough or a smooth, both cases the water wave will changes the direction. The lines in the diagram shown are the wave front. What is the meaning of the wave front? Example, if I say waves are moving from left to right. So this is one wave which is moving from left to right. This is another wave which is moving from left to right, example. Another wave moving from left to right. So there are so many waves which are moving from left to right. So it is difficult to draw all the waves because there are a lot of waves which are moving in this example from left to right. So instead of drawing the wave, what I can do, I can draw a wave front. What is a wave front? So wave fronts are basically imaginary line or lines which represent identical points of the wave. So lines which represent identical point of different waves, we call those lines as wavefront. So example, this is crest of one wave, this is crest of the second wave, and this is crest of the third wave. So if I join the crest, all the crest with a line, what I call this line is called wave front. Same thing, there's another, the second crest, this is the second crest, this is the second crest of the third wave. So when I join these crests together, what I will get? I will get the line, and this line is known as wave front. Same way, if we have crest of the first wave, crest of the second wave, and crest of the third wave. So crest means identical points. So if I join these identical points together by a line, what I call this line, I will call this line as a wave front. So instead of drawing so many waves, because practically it's difficult to draw a lot of waves and it is convenient. It is convenient to draw the wave front. So instead of drawing, we have to match all the points. Like example, identical points we have to match. So when we match the identical point, the line which join these identical points, these lines are called wave front. So if I say three waves are given, so three waves are given and the question is draw the wave front which shows crest. So draw the wave front to show or to represent crest. So this is the first crest or first wave, second wave crest, and third wave crest. So what I will do, I will draw a line. I will draw a line through these points, identical point example. And what I will call this line as a wavefront. Same thing, this is a second crest, second crest, second crest. I will join them with a line by a line, these points. And what I will call this as a wave front. Same thing, when I join the crest of the third point, I will also call that as a wave front. So what is the distance between the two successive wave fronts? What is this distance called? The distance between the two successive wavefront is known as a wavelength. Because the distance between the two successive crest is wavelength, so distance between the two successive wavefront is also known as wavelength. What is the significance of the wavelength? Just wavelength is a convenient way of drawing the wave. Like, because if I say you have a source of the wave which is producing many waves, so in this case it is difficult to draw all the waves. So for our convenience, instead of drawing the waves, what we draw a wavefront. Means instead of drawing all these waves, what I can do, I can simply draw wavefront, which is easy to represent the wave. And the direction of the, so basically what are wavefronts? They represent identical points of the wave. Like the waves are there, many waves are there, but instead of drawing all the waves, we just draw the wavefront. And the direction of the wave is always 90 degree to the direction of the wavefront. So if I say there is this is a reflecting surface, and these are the wavefronts which are moving towards the reflecting surface. The question is, what is the direction of the wave? Example A, B, C, D. What is the direction of the wave? A, B, C, or D? The wavefronts are moving towards the reflecting surface. What is the direction of the wave? And as I just mentioned, the wavefronts are moving towards the reflecting surface. So the correct answer is C. So direction of the wavefront is always perpendicular to, or direction of wave is 90 degree or perpendicular to wavefronts. So always the angle between the wavefront and the direction of wave is 90 degrees. So you can see B and D cannot be an answer. Why? Because they're parallel in this. So either A can be answer or C can be answer. A, if the wavefronts are moving away, if A was the answer, C is the answer because I mentioned in the question that wavefronts are moving towards the reflecting surface. So in exam type of question, they ask complete this diagram. What they will do, they will give you the wavefront and the question is complete the diagram. To show reflection of wave. So how you can complete this diagram to show a reflection of the wave? So first thing you will draw an arrow to show the direction in which the wavefronts are moving. So how you can identify the direction of the wave? Because the wavefronts are moving towards the reflecting surface. So this is the direction of the incident wavefront. So this is the direction of incident wave. Then you will draw imaginary line which is perpendicular to the surface or 90° to the surface. This imaginary line you have to draw, which is known as the normal. So then you will draw a normal, and using a protractor you will measure the angle between the incident and the normal. Example, if this angle is 30 degrees, angle of incidence is 30, what should be the angle of reflection? So if angle of incidence is 30 degrees, angle of reflection should also be 30. So you will measure the angle of reflection using a protractor. You will measure angle 30 degrees and show the reflected wave. But keep in mind the angle should be same. If angle of incidence is 30, angle of reflection should also be 30. Then you have to complete the diagram. So you have to draw the wavefront. So wavefronts are always perpendicular to direction of wave. And during reflection, this is called a reflected wave. And during reflection, only direction of the wave changes. But what happened to speed, frequency, and wavelength? The speed, frequency, and wavelength will be same or it will not change. Angle will not, sometimes they give you an angle, sometimes you have to measure the angle. Using a protractor, you have to place a compass, place a protractor or a D at this point and measure this angle. Using a protractor, you will measure the angle. Is it clear, the concept of reflection of a wave, that the wave changes the direction? When it strikes the surface. So a line joining all the crest or the trough is simply called a wavefront. Second property of a wave is called refraction. Refraction of the wave means property of a wave to change speed when moving from one medium to another. So when the wave travels from one medium to another, the wave will change the speed and we call that as refraction. Like example, because we are studying a water waves, so for studying a water wave in a ripple tank, a simple tank which is filled with the water and you can produce a wave, you call that as a ripple tank. So this is a ripple tank which is filled with water. In this ripple tank, how you create two mediums? How you can create two medium? So what you can do, you can place an object inside the ripple tank. So if you place an object inside this ripple tank, it will create two regions. One region, the water is deep. Another region, the water is shallow. So this is called a deep region, and the second one is shallow region. So in a ripple tank, how we create a region? We create a region by putting an object inside a ripple tank. So when we put the object inside a ripple tank, we have two regions. One which is having greater depth, so that's called a deep region, and the second one is known as a shallow region. So as the wave can travel, as you produce a wave in a deep region, so wave can move from deep to shallow, or it can, if you produce a wave in a shallow region, it can move from shallow to deep. So what you will observe when there is a movement from either from deep to shallow or shallow to deep, what you will observe, you will observe there is a change in the speed of the wave. The speed of the wave changes. So whenever the speed of the wave changes when it travels from one medium to another, we call this as refraction. If the direction changes, we call reflection. But if the speed of the wave changes, we call that as refraction. So example, this is a ripple tank and you are looking from the top. So this is a deep region and the second part is a shallow region. You are looking the ripple tank from the top and you produce the wave from the deep region. As the wave moves from deep region to shallow region, what you observe? What is happening here when the wave is traveling from deep region to shallow region? So as you can see, the wave becomes slower. And what happened to the wavelength? The distance between the two successive crests, what happened to the wavelength? So wavelength is also decreasing. So when the wave travels from deep region to shallow region, what is our observation? What we observe? We observe that the speed moving from deep to shallow region, it decreases, and the wavelength also decreases. So the property of the wave to move from one region of a water to another, and by changing the speed, we call that as refraction. What about the frequency? Frequency means number of waves in 1 second. But the frequency does not change. Why the frequency remain unchanged? Because if you recall the equation, look, if you recall why the frequency does not change, I will explain this idea. Look, you have this wave equation. Last time we discussed V is equals to F lambda. Speed of a wave is equals to frequency divided by speed of a wave is equals to frequency multiplied by wavelength. So if I want the frequency is equals to speed divided by wavelength. So what happened? Example, if in a Deep region, it was moving with a speed of 10 meter per second, and its wavelength was 5. What is the frequency? The speed of the wave is 10 and its wavelength is 5. So what is the frequency? Frequency is 10 divided by 5, so which is equals to 2 hertz. As it enters a shallow region, the speed decreases, the wavelength also decreases. The example, the new speed is equals to 3 meter per second, and the wavelength is 1.5 meters. What is the frequency? So when you calculate the frequency, speed divided by wavelength, speed is 3 and the wavelength is
Sir,
1.5.
how the speed decreases? How the velocity decreases?
Why the velocity decreases? Because shallow regions, the particles are very close to each other, so wave cannot travel quickly in a shallow region. You can understand from example, if you are standing at a seashore, so what you observe, you'll observe that the wave, it appear it's moving very fast when it is far away from you. But as it reaches the side, like seas, as it reaches the side or the seaside, so what happened? As it reaches the shallow region, you will observe the wave slow down. So why the wave slow down? Because the particle in a shallow regions are closer, so it does not allow the transfer of energy to take place quickly. So as the wave travels from deep region to shallow region, we observe the speed decreases, the wavelength also decrease, but the ratio between speed and the wavelength will remain same. So 3 divided by 1.5, that also gives 2 hertz. So frequency of a wave does not change as it moves from deep region to shallow region. The only thing which change is the speed and wavelength. Look, I'll repeat this part. The speed of the wave is 10 in a deep region and wavelength is 5. In a deep region, the wave can travel easily, so that's why it is moving faster, as the particles does not absorb too much energy. So speed is 10, wavelength is 5, 10 divided by 5, it's 2. As it enter a shallow region, the speed decreases, it was 10, become 3, and wavelength is 5, it become 1.5. So what happened as the speed and wavelength decrease, when I take the ratio between speed and wavelength, I will observe that the ratio remains same or unchanged. As the ratio remain unchanged, it means that the frequency remain unchanged. Direction can change during a refraction, but in this case, as the wave is moving exactly towards the from a deep to shallow region, in this case, there is no change in direction. So what is the observation moving from deep region to shallow region? We will observe that the speed decreases, the wavelength decreases, but the frequency, the wavelength gets shorter, but the frequency remains. So using a wave equation, using a ratio